Alrighty, here we are. And we are moving on into chapter 2. So the top of your notes should say compare and order rational numbers. And because, especially today, it's a very huge and long learning target, it's already pre-printed for you. So let's just double check that this matches, that you can compare and order positive and negative rational numbers, whether you write them as fractions, decimals, or integers. Okay, so that's basically what we're going to be doing today. All kinds of fractions, write them as decimals or fractions, so on and so forth. So here's basically what you're going to do, and we're going to do a ton of examples here. I'm going to change my pen to be a prettier color. 5/6, 7/10. Who's bigger? Who's bigger? Well, you have 5 out of 6 pieces of the pizza or 7 out of the 10 pieces of pizza. You got to decide which one means more. Well, there are a couple ways you could do this. One, since they already both are fractions, get a common denominator and then see who's got more. Because sixths are different size pieces than tenths are. If I had my pizza and it's cut into 6 pieces, it would look like this. And then if I have a pizza that's cut into tenths, this is going to be a little harder. Like 1, 2, 3. It would look like this. And my pieces aren't even that equal. Gracious sakes. All right, so it's hard. So if we can get a common denominator, so you're thinking, let's see, so 10, if I think my multiples of 10, 10, 20, 30, 40, 50, 60, and so on, which one of those denominators would work with the 6? Aha! 30 is the first one that works, because if I start doing multiples of 6, 6, 12, 18, 24, 30, shazam. There's the first one, or the lowest common denominator. Okay, how many 30ths would 5/6 be? That's hard to say. Times 5, times 5. Okay, so 5/6 would be the same as 25 out of 30. Okay, so if you cut that pizza into 30 slices, you get 25 of them. If I have this pizza that originally was in 10s and you make this a 30 slice pizza, you would have 21 30ths. Who's bigger? This guy is bigger. Okay, there you go. So that's one way you can go about it. Change everything into a common denominator. Okay, how about this one? I have 2/3 and 4/5. So if you start thinking about that, 2/3 versus 4/5, with a picture, you might be able to reason your way through it. Okay, 2/3 versus 4/5. It's hard for me to draw fifths, sorry. And I don't even know if that's very accurate, drawing all of this. Does this look bigger? It kind of looks bigger. Okay, 4 out of the 5 pieces versus 2 out of the 3. But mathematically, I want you to prove it to me by saying, well, a common denominator with 3 and 5. Let's see, 5, 10, 15, 15. There we go. Or go ahead and grab a multiplication chart and just go across the 5 row until you see where 3 is divisible, or divisible by 3. Here we go. This becomes 10/15. I have to multiply by 3 to get 15. So do the same to the denominator. Yep, you're absolutely right. 4/5 is larger. Okay. 1/2 and 2/5. Before we turn this into this, I want you to think about this. 1/2, I like this one because I visually can see it. It's just boom, exactly half of something. Is 2/5, is that smaller than a half or bigger than a half? In other words, what would this have to be exactly the same as 1/2? Look at the denominator, 5. So exactly half of 5 would be 2.5. This is going to be less than. I can see it already. How do you prove that? You can prove it by getting a common denominator. Okay, this is 5/10. This is 4/10. If you really like decimals better, this is 5/10 this way. This is 4/10 this way. Okay. But this one, 1/2 is larger. Okay. How about these guys? Do you like decimal way better? You know, I'm not letting you use a calculator yet, so that's why I've been sticking with fractions. But, you know, if you happen to know your decimals really well, 3/4, you might have that one right off the top of your head as 75/100. 2/3, if you don't remember that, remember this means 2. This means divided by 3. And when you start doing the long division here, 3 can't go into 2. 3 can go into 26 times. Get 18. Hey, I'm going to notice right away in my 10ths position, I'm already smaller, so it's going to be smaller. This guy actually ends up being 0.6 repeating, and so that's why it's smaller. If you stick with fractions, you would turn it into 12ths because that's the common denominator between thirds and fourths. And this becomes 8/12 versus 9/12. They're very close, but 2/3 is still smaller. Okay? All right, what if you have a whole number in front? Okay, notice here 5 and 5. Hey, they're tied so far. Really, what you're after is the fractional part, the 2/9 versus the 2/7. Okay, let's think about this. Think about this for a minute. I have 2 pieces out of 9 in the pizza. Okay, so my pizza is cut into 9 pieces. Okay, oh, this is a horrible model. Okay, but think of it. My pizza is cut into 9ths. I get 2 of the pieces versus this pizza, which is cut into 7, and you have 2 of those. This guy's going to be bigger. It's going to be bigger. Here's another way to look at it. Change it into a common denominator. Because frankly, both of these, turning it into a decimal is possible. Okay. I happen to know what they are as decimals because I've done them for so long. But when we're doing them by hand, I kind of think fractions are our friends. All right. 63 is the first number that works. In fact, you could always multiply the 2 together to get a common denominator. You may not always get the smallest one or the least common denominator, but you always get a common one. In this case, this is the least common denominator. So 14/63 times 9/9. 18/63. Yes, that's that. Okay, again, look at these two, 4 and 2/9, 4 and 3/5. As long as the 4 is the same, that's tied so far. You have to look at the fractions, 2/9 and 3/5. Sometimes you could reason your way by saying 2/9. That's way less than 1/2 because exactly half, this number would be 4.5 over 9. What would be, is this bigger or smaller than 1/2? 3/5, 3/5. Okay, exactly half of the fifths would be 2.5. So this is greater than 1/2, which means since the 2/9 is less than 1/2 and this is bigger than 1/2, I can tell you right now it's going to be less than. But you have to prove it to me. Prove it, and get me a common denominator. Okay? Because it's not like magic fairies are just going to come and sprinkle pixie dust on your beautiful brain and you can just do it without showing me some work behind it and the reasoning behind it. Getting it to 45ths, this is 10/45. Getting this to 45ths is 27/45. Whew! Definitely bigger. Okay, what if you have negatives? Well, hold on here. -44 and -2/5. I don't know, which way do you want to go? Sometimes it might be easier to stick with fractions. Sometimes, if I already have this guy as a decimal, it might be easier turning this guy into a decimal, huh? 2/5. 2 divided by 5. Oh, that's a nice decimal. It's just 4/10. Now, what's bigger here? Well, hold on. This has 2 places. Let's make this have 2 places. Normally, I would say 44 is larger than 40 when we're in hundredths, but this guy's negative, and that means things turn around. This should be a less than sign, okay? Next, let's see. Here, what you should end up with, let's see, you have a decimal and you have a fraction. Frankly, what I might do is leave this guy as the decimal, turn the -4/5 into a decimal, because that one works out quite nicely. Oh, look at that. You get exactly -0.8. They're equal to each other. Okay? Sometimes it's a little easier to work with decimals. Sometimes it's a little easier to work with fractions. Okay, what about these guys? I don't know. Since I already have this guy as a decimal, I might take 5/6 and turn that into a decimal. Let's see what happens. I get 8, so I'm tied so far, but here's the deal. This one has not stopped. In fact, I'm going to get a 3, and as I continue on trying to turn this guy into a decimal, you see what's going to happen. This ends up being 0.83 repeating. This is just 0.8 or 0.80. The 5/6 wins as the larger value. Okay. All right. As we look at this next one, and I am going to have you look at these. It says put them in order from the biggest to the smallest, or smallest to largest. And I give you a number line as kind of a resource. You know, -3.4 is going to be right about there. -2.5 is going to be right about there. 14/4 and 6. Well, here's 6, or 6.0. So now the question is, where is 14/4 on the number line? Well, let's get that in simplest form here. 14/4 is the same as 7/2 as a fraction, which is 3.5 as a mixed number. So here's where 14/4 is right there. So here's your order. That's why using the number line, frankly, sometimes is very helpful. So write your list this way: -3 4/10, -2 5/10, 14/4, 6. I think there's one more of these, okay? If you have a number line, you can use it, but really you're looking for your negative values first, which means this guy is the most negative. Then comes -2 2/10. Then I've got these two. Which one comes next? Well, 7/2. 7/2 is the same as 3.5. So it looks to me like this guy comes next, and then 7/2. So you have decimals, you have fractions, you have mixed numbers. Some are positive, some are negative. You've got a whole lot that you're putting together here, okay? Look at this last one, I think. Sarah competed in this long jump contest. This was her first one. Then this was her next one. And this was the third one. Which jump was the longest? Well, I would probably turn these all into decimals. Here's the first one. That's already there. 3 8/9. If you take 8/9, come off to the side, do some division, and figure out what this is. 8 divided by 9. Here's what happens. First of all, I wrote that wrong. 8 divided by 9. You get 8 and another 8 because you get 72. This is 3.8 repeating, 3 and 9/11ths. This one, 9 divided by 11. This also lands you in the 8s, but let's see what happens here, okay? Because this guy is 0.88888. This one, I get a 2. Bring down this, we get a 1. Then I get 11. I get a 9 again. And as you keep dividing, this ends up being 3.818181. So which one is the longest? Not that one. Both of these have 8s in the 10th position, but this one has 8s in the 100th position. So 3 and 8/9 meters is the longest. Whew. There we go. Fractions, remember, are our friends. So here's what I want you to do. Your assignment, check in Schoology or check the whiteboard right in front of you. Good luck, and may the force be with you.